Welcome to this video, which is an introduction to the use of subclasses in entity relationship diagrams. My name's Andy Wicks, and what I'd like to do is to show you around how all of this works and even why you need it. Well, let's start with a database problem. Anybody who's ever built a real database knows that you find situations that just don't fit nicely. For example, you create an entity and you find that you're putting in fields that will be empty for most records. Some fields will only get filled in if a record is of a specific type. So if a person is of a type manager, or if a property is of type rented. And this means that you're wasting valuable disk space. You're also making your database inefficient, and that is not a good idea. So if there's a problem, there's probably a solution. The problem starts with clients. The client knows exactly what they want. They know their business. However, things that are obvious to them will not be obvious to you. You discuss your conceptual diagram with the owner of the second-hand bookshop, and what you find is that the bookshop owner would like to know whether the book is hardback, paperback, comic or magazine. That's all right. All I'll do is add an extra field to say whether it's hardback, paperback or comic or magazine. But unfortunately the bookshop owner has other ideas. You see, there are more problems. If it's a hardback book, does it have its original dust cover? If it's a comic, who is the illustrator? And if it's a magazine, who is the main photographer? And if it's a paperback, there are no special details needed. It's just a book. This affects the book table. So let's start there. The book table we're working with is at the conceptual ERD end of the design process. So this is where we're going to start. Notice that it doesn't have any fields, it's just got a primary key. Now we need to add in the extras. We need to add the hardback, comic and magazine entities, but not the paperback one. So we have hardback, comic and magazine over to the right here. Now we have a decision to make. This is going to sound a little complicated, but you soon get the hang of it. Is this relationship disjoint? So is an individual of the parent class, in our case book, a member of only one specialised subclass? So in this case, that's a possibility. Or is it overlapping? An individual of the parent class may be a member of more than one of the specialised subclasses. Well, in our case, the subclasses, the extras that we added, are disjoint because a book cannot be, say, hardback and a magazine at the same time. These are disjoint entities. So let's add that to the diagram. We add a D for disjoint, or an O if it were overlapping. So in our case, we put a circle with a D in it where all the lines intersect. And that is our disjoint relationship. So we have our subclasses. The first decision, disjoint or overlapping, is made when we're in the conceptual ERD. We now have to resolve these subclasses. Resolve means something we can use when we're looking at things that are further on than the conceptual ERD. This is the starting point for the changes that need to be introduced for the logical and physical ERDs. And for that, we have to make a second decision. The second decision also sounds a bit complicated, but again, once you get used to it, it's quite easy. Is this a partial relationship? Some individuals of the parent class are specialised, so some have unique attributes, whilst other individuals are of the parent class only. Or is it complete? All individuals of the parent class have one or more unique attributes that are not common to the generalised parent class. Well, in our case, it's a partial situation because the paperbacks do not have any added data. So they are separate to the hardback, comic and magazine. So we now know that our subclasses are disjoint partial. The next step is to consider what each of the four possibilities would look like. The four possibilities you could have are disjoint partial, which is what we have, disjoint overlapping, complete partial, or complete overlapping. We're going to discuss the disjoint partial first, and then we'll move on to the other ones as well. So, disjoint partial. Each new entity here inherits the primary key from the parent as their primary key. Up until now, we've always had the primary key being the name of the entity plus ID. Well, for subclasses, this isn't the case. Subclasses inherit the primary key from their parent. We can do this because they're in a one-to-one relationship. If you imagine that you have a book in your hand, that book could be paperback, hardback, comic or magazine, but it is still only the one item. So even if it's a hardback, there's a one-to-one relationship. You can take the primary key from this hardback book and put it in the hardback table as well. For a specific book, it may have its own extra information. If it doesn't have the extra information, it must be a paperback. We will therefore get something like this. In the physical ERD, a book may not have an entry in hardback, therefore its cardinality is one book, possibly 0 hardback entries. However, there must be a book for there to be a hardback entry. So you couldn't have an entry in hardback without there being a book for it. In this case, therefore, we get something like this. We get book being compulsory, mandatory, and the other 3 being optional. There may not be an entry in hardback or in comic or in magazine for a particular book. But what about these other possibilities that we talked about? We know what happens in the second-hand bookshop scenario, so we'll use a new scenario. Imagine that we have an entity called artist, and for artist we have subclasses called sculptor and painter. We're going to use this example for the other possibilities. Don't have specialised. Before we start on those other 3, let's have a look at how this would look if we were just using the situation that we've got. So the equivalent for our situation would be something like this. Someone can be an artist, or they could be a painter, or they could be a sculptor, or there may be other kinds of artists as well that don't have specialised fields. This is what we have. We use the primary key from the parent in that possibility, and we use the primary key from the parent again if we have partial overlapping. So for partial overlapping, someone can be an artist or a painter or a sculptor or any combination of these. So an artist would have a talent. An artist may be a painter, an artist may be a sculptor, or an artist may be a painter and a sculptor, in which case the artist would be in a one-to-many relationship with a talent. If they were just an artist, there'd be no talent. If they were an artist and a painter and a sculptor, there would be 2 entries for this particular artist in the talent table. The primary keys are still being used in the child for complete and overlapping. So someone can be a painter or a sculptor, but they're both artists who have shared attributes. In that situation, again, talent would have artist ID as its primary key. And finally, if we have complete disjoint, then each would have its own primary key. Complete disjoint, someone can be a painter or a sculptor, but not both. And the fact that they're artists would be fairly irrelevant. So there would be a painter ID in painter and a sculptor ID in sculptor, and the artist table would disappear. Well, I hope you found this useful as an introduction. Thank you for watching.